see you. I saw you come in. So today we have the quadratic formula, and you guys will be happy to know that they reverted the old whiteboard back, so we won't have that glitchiness that we had with the last one. The quadratic formula, the last time I saw you guys, we were talking about completing the square, and I said you can use completing the square for any quadratic, but sometimes it gets really complex to work with, right? Hi, YouTube. The numbers will get crazy and the steps go insane, but the quadratic, I don't know why I called it the quadratic factor. It's the quadratic formula. The quadratic formula works for anything as well. And literally all you have to do is be able to know what to plug in. Look, I almost did it again. I told you I'm really tired today. The only thing you have to do to understand the quadratic formula is know where your A, B, and C come from. And we have been working with quadratic equations of the form ax squared plus bx plus c, right? That is our standard form of a quadratic equation. For the most part, we're going to want to have it set equal to 0. The quadratic formula itself is when we're solving for that x, it is x equals minus b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Do you have to memorize this formula? It might help you down the road, but for the purposes of this class or your test, no, because you're home. You can have it right in front of you. The main thing to understand is where we get our a, b, and c are from this equation. Our a is whatever is in front of x squared. Our b is whatever is in front of x. And our c is that constant, right? And so if we want steps, I know I have a lot of students who like steps when they can get them. So steps to solve using, we'll call it using QF. So I don't have to spell out quadratic formula. Number 1, if necessary, rewrite equation in standard form. Standard form is set equal to 0, right? In varying degrees, in order of degrees. So ax squared plus bx plus c equals 0. Basically what we're saying is we want everything set equal to 0. Number 2, identify what a, b, and c are and plug into formula. Three, solve and simplify. I think the best way to show the quadratic formula, I think the best way to show most things is by example, right? And so we're going to start with some easier examples and we're going to move into some more difficult examples. I want to try and get as many examples in as I can, or at least as many types of examples as I can, so that you can see them with square roots that don't break down. You can see them with imaginary numbers, so that you have like a video example to refer back to when you're doing your homework for basically any type of problem. The first one we are going to start with is example 1, because that makes sense, right? To start with 1. Is x squared plus 2x minus 63 equals 0. Now, if we look at that first step that says to rewrite the equation in standard form, this one is already in standard form. It's set equal to 0. Our powers are decreasing, right? We've got our x squared, then our x, and then our no variable whatsoever. And so we can move on to part 2 where we identify A, B, and C, right? A for us is whatever is in front of x squared. If there's nothing in front of x squared, it's just 1. Our B is whatever is in front of our x value. If there is nothing in front of our x value, it's 1, but because we have a number there, it is 2. It is sign sensitive, so if this was a negative, it would be -2. Our C value is whatever doesn't have any type of a variable, right? So that is just -63. And now what we're going to do is we're going to plug these into our quadratic formula, right, for A, B, and C. So we have x equals minus b. Well, that is -2 plus or minus b squared. Well, that is just 2 squared minus 4 times a, which is 1, and c, which is -63, because that's a pretty number, all over 2 times a, which is 2 times 1. Right? Now, if you notice, we've pulled all the variables out. We don't have variables in there anymore. Everything is just solving a numerical problem. Always start with what is underneath your square root. Think of it as a grouping, like in PEMDAS with the parentheses as a grouping. Deal with what's under that square root first. So I'm going to start with writing my -2 plus or minus just to have it out of the way. And I'm going to do the math under here. 2 squared is 4, right? -4 times 1 is -4 times -63 is plus 252. Right? And I'm going to write this all over 2 times 1, which is just 2. So if I rewrite this, it's -2 plus or minus the square root of 256 over 2. Right? That is almost our answer, but this is not a simplified version of the answer, right? Notice that it is 2 answers, right? It's going to be -2 plus the square root of 256 over 2. And it is going to be -2 minus the square root of 256 divided by 2. And lucky for us, the square root of 256 is a nice round number. It is actually 16 times 16, right? 16 squared equals 256. So this is -2 plus or minus 16 over 2. Will it always break down nicely like that? No. So when I look at this, I want to look at it as the 2 separate answers, right? It's -2 plus 16 over 2. And it is also -2 minus 16 over 2. That's what that plus or minus means, right? And it makes sense if you remember when we were graphing these, we said that the solutions were those points where the parabola, that U shape, crossed the x-axis. And it would always do that in 2 points, unless it was the vertex, right? In which case you would see what that looks like. You'd be like, why am I only getting one answer? Or why is this a 0? Are these my answers? We go -2 plus 16. Well, -2 plus 16 is 14. Divided by 2 is 7. -2 minus 16, well, that's -18. Divided by 2 is -9. So our x equals 7 and -9. Make some sense? That was a nice problem, right? It broke down really easy. Let's look at another one. Let's look at a whole bunch of them. A ton. I know you want to. I don't want to go up too fast in case you guys are writing stuff down. I don't even know if you guys are taking notes at home. I can't see what you're doing. I hope you are, though. Let's do example 2. Why? Because it's the second one. Example 2. Example 22. If I have minus 2x squared plus 3x equals 4x minus 15. The first thing that I have to do with this problem, if you recall, is rewrite that equation in standard form. I need that set equal to 0, right? And how am I going to do that? I'm just going to move these pieces over. I have positive 4x, so I'm going to subtract 4x from each side. I can do both pieces at a time, but I'll separate it just so you can see. Right? And this is going to give me minus 2x squared minus x equals negative 15. Still not set equal to 0, so I'm going to just add 15 to both sides. And I get minus 2x squared minus x plus 15 equals 0. Right? The next step was to identify my a, b, and c. So my a is whatever is in front of x squared, and in this case, that is negative 2. My b is whatever is in front of x. Notice I just have a negative there, so that is just negative 1. C equals 15. It is my term with no x value. And now I can plug these numbers into the quadratic formula. The quadratic formula is x equals minus b, so that's minus negative 1, right? The formula, if you look, is negative b. If I'm putting in a negative number, I can't just erase the fact that it already had a negative in front of it. So make sure that when I'm putting in that negative 1, that I remember that it's negative 1. Does that make sense to you? You're getting that, Shaylin? Did everybody get that? Okay. Thank you, Sergio. Madison, thank you. So here I have that negative 1. I've got plus or minus the square root of b squared. So we're going to go negative 1 squared. Always put it in parentheses because you've got to square that negative as well. Minus 4 times a. Well, our a is negative 2. And times c, which is 15. All over 2 times a, which is negative 2. Now we're not dealing with any variables. We only have numbers solving those problems, right? How are we going to do it? We're going to do what's under the parentheses first. So I am just going to rewrite this part. I'm going to go ahead and combine that negative and just go 1 plus or minus the square root of, well, let's look at this. 1 squared, negative 1 squared is just 1. Negative 4 times negative 2 is positive 8. 8 times 15, what are you? 8 times 15, 120. Just checking the math in my head. Plus 120. Oh, that's convenient. I put 121 because I actually added them together in my head first. $120 all over negative 4. Well, that's the same as saying 1 plus or minus the square root of 121 over negative 4. Does anyone know what the square root of 121 is? Honestly, anytime you're working with square roots, it really helps to have like those either memorized or a list of them. Trinity's got it. 11 squared is 121. So we can pull this out now as 1 plus or minus 11 all over negative 4. And when we look at that, we have to understand that it's 2 solutions. The first solution is 1 plus 11 over negative 4. And the other one is 1 minus 11 over negative 4. And do you have to separate these all the time? No, but I always do when I'm teaching it so that you can understand that they're two. Normally, I just figure them all out in my head, and I'm sure you will get to that point. But so 1 plus 11 is 12, divided by negative 4 is negative 3. 1 minus 11, well, that is negative 10, right? This is negative 10 over negative 4, right? I hate it when it does that. And when I reduce that fraction, that just becomes 5 halves. Becomes a positive 5 halves because it is negative over negative. And so we know that our x equals negative 3 and it equals 5 halves. This is not or, it equals both of them, right? Because there are two solutions. It's saying that when we graph this equation, this is a terrible drawing, right? I've got 1, 2, 3, right? Negative 3, 1, 2, 3. So here and here is where that graph is going to cross. It's actually going to go like this because that was a negative, right? But those are going to be the spots where it crosses the x-axis. So it's two solutions. It can't be or, because that just means that it can be one or the other. It has to be both for it to be correct. Right? Is that making some sense before I move into harder problems? Actually, the next one will be super easy, and then I'll move into harder problems. Sarah, do you understand what's going on? Are you getting it? Are you following me? Kinda? Okay. Maybe it'll make more sense in green. That's really all about the color. What happens if I picked up the wrong pencil? What happens if I have an example like 8x squared equals 10x? If we're following the rules, we have to move this 10x over, right? Because we have to have everything set equal to 0. So I'm going to go ahead and subtract 10x from both sides, and I get 8x squared minus 10x equals 0, right? And then I go to find my a, which is 8, and my b, which is negative 10, and my c, which is, there's no c. What happens if I don't have a c value? I like the question mark, and you are absolutely right. We just make it 0. If there's no c value, we make it 0. The same thing if I'm working with something that doesn't have, say, like a b value, like a 10x, like there's no x value, we would just make it 0. The only thing we can't ever have be 0 is a, right? Because then it would make that x squared 0, and it's no longer a quadratic, right? The only thing we have to make a quadratic work is an x squared. And if we have the a term being a 0, that makes it a 0. It's no longer quadratic. We can't use it anymore. So when I go to plug this into the quadratic formula, I'm going to go x equals minus b. Well, that's minus negative 10 plus or minus the square root of negative 10 squared minus 4 times our a, which is 8, and our c, which is 0, which just made the math really easy, did it not? Think about that a little bit. Over 2 times 1, 2 times a, which is 8. If we look at that now, we've got negative 10 times negative, which is just 10, plus or minus. The square root of negative 10 squared is just 100. Well, minus 4 times 8 is 32, but what happens when I multiply that 32 times 0? Exactly, right? So literally there's nothing right there. This is as good as it gets. 16, right? What is the square root of 100? What number times itself gives me it's not undefined. Because we still have the square root of 100. We still have the 100 there. We just have nothing to. So the square root of 100 is 10. Thank you, Trinity. Over 16. So I have two solutions here. I'm already there. The math got easy because we multiplied by 0. We have 10 plus 10 divided by 16. And we have 10 minus 10 divided by 16. If I look at this, this is 20 over 16. Can I leave that like that? Everybody better be saying, now, Jacob, you're being so quiet today. It's so uncharacteristic of you. No, we have to reduce it, right? They're all at least divisible by 2. I'm going to go ahead and jump in and say, hey, they're each divisible by 4. And go, this equals 5/4 for the purpose of saving a little bit of time. 10 minus 10 is 0 over 16. What is that? What's 0 divided by 16? Thank you. Yes, it's 0. Some people might say undefined, but you can divide into 0. You just can't divide by 0, right? So our solutions here are 5/4 and 0. Those are the areas, those are the spots on the x-axis where this parabola is crossing. Let's look at some ugly ones because you're going to get a couple of ugly ones on your homework. I posted a sheet for you, a worksheet on, well, it's not posted yet. It will be as soon as I'm done with this class today. The worksheet that I had has 12 problems on it, and I was going to have you do all of them, but these are kind of work heavy, so I think I'm just going to have you do all of the even numbers instead. So you'll have 6 homework problems, and that's it. Right? And I like it doing even because they get progressively harder. And so let's look at I don't know what color to do it in. Let's do this color. I don't even know what example number I'm on, so I'm just writing example. I like this one because this one is complex. X squared minus 9 equals 4x. First thing we've got to do, we need to move that 4x over, right? So I'm going to do that by subtracting 4x from each side. And I'm going to rewrite the problem as x squared minus 4x minus 9 equals 0. I'm in that standard form, so I'm going to go ahead and identify my A, my B, and my C. In this case, my A is just 1. There's nothing in front of that x squared. My B is negative 4, right? Because that's what's in front of the x. And my C is negative 9. And so I can start plugging those in. X equals minus B. Well, minus B is minus 4. Minus. I hate saying minus. Plus or minus. B squared. Well, that's negative 4 squared minus 4 times our times our A, which is 1, and times our C, which is negative 9. All over 2A. All over 2 times 1. So now it's time to clean this mess up. Negative times a negative gives me a positive 4 plus or minus. We're going to deal with what's going on under here. 4 squared, that is just 16. Negative 4 times 1 is negative 4. Negative 4 times negative 9 is positive 36 all over 2. What is that? That is 4 plus or minus the square root of 52 over 2. Is that reducible? It's not a perfect square. 52 is not a perfect square, which means that I have to break up that 52. I have to see what I can pull out of it, right? And so I'm going to look at those factors of 52. Well, I know that 52 is 2 times 26, and I know that 26 is 2 times 13. So I can pull the 2's out, and I'm still left with that 13. So ultimately, I have 4 plus or minus 2 times the square root of 13, all over 2. Can I leave it like that? No. Right? This is divisible by 2, and this is divisible by 2. 4 divided by 2 is 2, plus or minus 2 divided by 2, which is 1, but we still have that square root of 13. Can I leave it like this? Yes. How do you know I can leave it like that? I put a box around it. Right? So I know I'm done. Do I want a decimal answer on this? Absolutely not. If you plug in that square root of 13 and give me a decimal, I'm going to cry. And I'm also going to tell you it's wrong. Right? We don't want decimal answers. This is how we want to see these problems. Because if you plug in a decimal, it makes it unusable for us in more complex math where we might need to be using this formula, using these numbers. I know you like your decimals because that's what your calculators give you, but fractions are better math. What were to happen if, say, we forgot all this, right? And we got to the end and we had a solution that is 4 plus or minus the square root of negative 52. And we can put it over 4 again, right? Or 2 again. So we have the same answer, but we have a negative under the square root. Does anybody know what we would do with that? Sergio, you're my hero today. I'm telling you. Oh my God, man. It's an I, right? Anytime you have a negative under a square root, you can just pull it out as an I. So if I'm looking at this, I could rewrite it as 4 plus or minus I times the square root of 52 over 2. And then I could go ahead and break down the 52 the exact same way that I did before. So I would have 4 plus or minus 2I times the square root of 13 over 2. And when I reduced it, it would be the same, right? I'd have to divide that by 2, and I'd get 2 plus or minus I times the square root of 13, right? That is the only difference between that. And I think that was easier than me doing a whole other quadratic problem with an imaginary number, is just to show you what would happen if that solution had been imaginary. Any questions from any of you? Do you kind of get it? I tried to show you as many examples of different types as I could in the limited amount of time that we have in this class. Is there anything anyone wants to see? I'm trying to see if I've got anything that doesn't break down. And I think I got you an example of at least every type of problem you might see in terms of the homework goes. Pay particular attention to the steps, right? What do I do first? I rewrite the problem so it's set equal to 0. I'm trying to find it over here, right? Rewrite in standard form so it is set equal to 0. Make sure it's in declining degrees. Know what your A, B, and C are and just plug them. into the formula and then simplify, right? If you're struggling with it, I have tutoring hours today from like 1:15 to 2:45. I will be in here tutoring. The earlier the better, though, because Miss Walters from next door is going to come in and teach me something towards later in the day.
I have a question. Is the code for that the one in Little Classroom that says Hoy support? Because I was trying to get into it Monday and it went there.
Yeah, if that ever happens, just shoot me an email. It might mean I just had to like go somewhere, and so I didn't have it open when you tried to get in, so that I know that you're looking. But normally I just have it open.
Okay.
So I don't know what I had this Monday. I think I left early this Monday. I did leave early. But yeah, you just type Hoy support and that'll get you there. If you do Hoy math too, I keep them both open just in case, because nobody ever remembers to use the Hoy support one. What am I learning, Valerie? I am learning how to use something called CTI Navigate for my other job, which is helping process teaching candidates for the district. It's another job, but it's another job within this school district. I have 3 jobs. I have this job, I have that job, and I process the independent study folders because I have 4 kids and they all seem to want to go to college. Like 2 of them are in college. And I got to pay for all that. And it's just me, man. I'm just a mom. What can I tell you? You should get one. A lot of places are hiring right now, Jacob. If you can. You know, sometimes it's hard to get a job when you guys are younger. Nobody wants to hire younger people. It's like they're biased against you. I think it's about the number of hours you guys are legally allowed to work. That is all I have for you guys today. I'm going to stop this video. People are going to watch.